Alright, from our previous video that is concerning the load distribution on arches, or how arch distribute the load. So we saw how the forces are acting on the arch structure, or how the load is being distributed, or it's how the weight is carried by the arch. So today I'm going to demonstrate on how again those forces still act on the arch, and how the arch will fail if failure occurs. So I've got two demonstrations here. So our two timbers, we take them as arches, or we assume them as arch. So you can see the first timber that is behind this broken timber. So the first timber, which has a stone weight on top of it, so that is an arch that has not failed. And the one in front, the one that has failed, or rather the one that has broken, that is the arch that has failed. That is due to the forces that were exerted on it, or due to the weight that was exerted on it, that is by putting that stone on top of it. So you see the point of failure of that timber, which we assume is our arch. So the failure of an arch doesn't occur at the center. The failure of an arch, it occurs just adjacent, or just immediate after the center. So for example, this is where our arch failed, this is where our timber failed. So I am assuming here this is a support, this is a support, and also on the other end that was the support for this arch. So when we loaded the arch, using this stone, so the arch could not withstand the load, hence it failed. So you see here at the support here, we have a compression force whereby there is that reaction force from the support. So the support is tending to push the load back, and also this load now that is exerted on the arch, you can remember from our previous video, the way I told you how arch distribute the load is that the arch distribute the load that is in line with the curvature. So the load was following the curvature. That is how the load was being distributed. So that curvature, or rather that load that is being transferred to the curvature, it is a compression force. So these two compression force, the force that is coming from the weight, and the force also that is acting at the support, which is countering the load. So here at the support we have the compression force actually coming from the load, and also the compression force that is reacting upwards, that is by the support to counter the force from the load. Therefore the failure actually occurs. Let me show you from this one now, the one that is loaded. So you can see the loaded arch. So we have this load, it is being distributed along the curve, and here at the support we also have a reaction force that is countering the load force. So this reaction force that is from the support is countering the load force. So we have that compression force towards the support, and also we have the compression force that is reacting against, that is by the support, it is reacting against the load. So you will find that the failure of this arch, it will not occur at the center where we have the loading. No, neither will the failure of the arch occur at the end where we have the support. The arch will tend to fail at this point here, because we will have this force that is from the load, the compression force from the load, and we have also the compression force that is from the support. Therefore, this point is where we'll have the failure. So this is where this arch will break, and it will break upwards. So because this force, remember this compression force, it is tending, or rather it is being distributed along the curvature, and as it is distributed along the curvature, it tends to make this curvature to acquire a flat shape, or rather it is trying to make this curvature to bulge outwards. So as it tries to bulge outwards, so you will find that this force will come like this, and we have this reaction force from the support that is coming upwards. Therefore, that's why we have the failure here. So that is just an explanation on how the failure occurs to an arch. So this is our support at this end, and also on the other end, that is our support. So those supports, they are acting against the compression force that is being applied by the load. So this load is actually applying the compression force, and this force is being distributed, that is along the curvature. But you find that at the end of the arch, where we have the support, so that support also, it is pushing upwards. So it is counteracting the load that is being distributed along the curvature. So the failure will occur here, because that force from the support acting upwards, and this force that is applied by the load along the curvature is acting downwards. Therefore, the failure will occur like this at the corner. So that is how the failure of arches occur, because we tend to have, you can remember from our previous video, I told you that on arches, we tend to have more compression force acting on them as compared to tensile forces. So I hope that has been understood well on how failure of arches occur, that is upon load application. So we just do a recap again. You can see the first one is the sample of our arch, and it is loaded. That is, we have applied a load using that stone. So you can see that thin timber, which is an arch, is able to withstand that load. But now I was just trying to demonstrate on how the arch fails. And I have said at the end here we have the support, and this support is reacting against the load that has been applied, whereby this load is being distributed along the curvature. Therefore, the arch will fail at this point. This is where the arch will buckle. This is at the point where the arch will buckle, or that is the point where the arch will be broken. That's where it will fail. So as you can see on this demonstration of another arch, so this arch, it has failed at this point. So you can see that is the support, and also this is the support on this side. So the center of this arch was somewhere here. The center of this arch was here. This is where we had applied that load. So you can see this is where the arch failed. So that is how arch failure occurs.